I had forgotten to stop the Zoom session and was looking at grades and stuff, so I had to edit it. It's terrible. Did you guys have a good spring break? It was kind of winter break for us. I hated that. I would have liked better weather. It was just cold. Okay. So we're going to look at repetition. There's different ways we can loop or repeat code in a program. So we saw before spring break with our if statements that we could control which code executed based on a condition. You know, if this is true, then execute this code. If not, execute some other code. So we might also have pieces of code that we would like to execute repeatedly, like over and over and over. And so we have control structures in our programming languages that let us do that also. It's an important logic concept for us to be able to do that. So when we're looking at repetition or looping, where won't work. I don't know what the magic is. Maybe if I plug in the USB dongle, that magic might help. Let's see. Oh, it's much happier now. So when we were looking at if statements, the first thing that I hit you with is the condition. And I said, when we're looking at if statements, we have this big condition issue. What is the condition that we're looking at? Is the stoplight red? If so, we're going to stop. What is the condition that is of concern to us in our program? And we saw that when we have a condition in a flow chart, we illustrate that with a decision diamond, and we always have a true path and a false path. Well, why would I bring that up when we're talking about repetition? Because a lot of times we want to repeat code based on a condition also. So until something's true or while something is true, we want to repeat a chunk of code. So let's think about this looping process then, if we want to repeat some code. Here I have a flowchart chunket. We have a starting and we grab some data, ask our user for something, and then we make a decision. And in our decision, again, our decision diamond, we have a true or a yes path and a false or a no path. Well, in this case, if we take our no path, we do some sort of processing, but then our logic branches back to that decision again. We say, is that decision true now? If not, do that process some more, and then check that decision again. Is it true now? If not, continue processing. So we're going to keep doing that process over and over and over until our decision finally results in a true or a yes. Now, in this case, we're looking for a yes. We could be looking for a false condition there to end our loop too. We can control that completely however we want, and then we can continue on. So when we're looking at a flowchart, we're going to see some sort of backwards branching like this that shows that looping is happening. All right, so nothing else special in a flowchart to show that repetition. Here again, we've got some data. We're making a decision. This time, if the decision is true, we're going to execute some process and be done. If it's not true, we're just going to be done. So we can change that decision diamond from being a loop to just being a regular decision diamond just by the flow of our arrows. And if you remember when we were doing flow charts, I was real harpy about it, said the arrows matter a lot. Well, now we see why they matter a lot, because if we didn't have arrowheads on there, we wouldn't realize what was going on in that repetition. So whenever we're forming our condition, just like with an if statement, we're going to build that test condition based on whatever we want to result in a true or a false value. So we're going to use those same relational operators to build our condition. We saw that Python's maybe a little bit different because we have like the word not instead of that exclamation point. We'll see them pretty much the same. Remember with our condition, we have to have two sides, two operands. the left side and the right side, the left operand and the right operand, to have things to compare to each other. Those operands could be variables. They could be literal strings or numbers or whatever we want in that test condition. So just exactly the same. Now, some new stuff when we're talking about looping, some things that matter. An iteration. An iteration is one time of executing our loop. So that's kind of a math term that might be familiar to you. It might not. I know the first time I heard it in a programming class, I had no idea what they were talking about. So it took me a little while. But that just means one time I execute the loop. So what's a good looping thing to think about? One that's, what's that? Where you've got all the chairs and they play the music and you're walking around. Musical chairs. That one's kind of loopy-like, isn't it? Because as long as the music is playing, you just keep walking around. When the music stops, you try to get a chair and sit down. Well, each time that music is playing, from the time it starts until it stops, is one iteration of the game, right? So we've had that thing happening. Now, the loop body is what is happening while our condition is true or while our loop is going. So if we're playing musical chairs, our loop body is just the people walking around the chairs waiting for that music to stop to sit down. And that's what's happening repeatedly until that condition happens. And finally, an infinite loop we wouldn't want with musical chairs, but it's one that never ends, and it's really bad. You might have encountered some when you've been working on the internet. If you see a website or a game or something that seems to hang for a really long time, and then it finally cancels, gives you some sort of weird error message, that's usually because something went into an infinite loop, and the system finally saw that it wasn't going to ever end and just killed it. So whenever we're writing loop code and looping logic, we want to save often and make sure that we're keeping track of what we're doing, because it's real easy for us to write programs that can cause trouble. All right, when we're creating loop code, we could test the condition before we loop. That's called a pretest loop. You'll see this in your textbook. But I'm deciding here if I want to go into a loop before my loop body executes. So if my condition is true, I'm going to execute my loop body, and I'm going to continue executing it. And we'll look at some of this here in just a second, hands-on, so I'm just kind of skipping through quickly. When we're putting in a looping construct in our pseudocode, there's lots of different ways to do it. There's no perfect good way. If you are forced to write pseudocode that has a loop in it, you could do it like this. In this case, it says while this condition is happening, the loop body is indented just kind of like it would be in Python code to show that it's part of the loop. And then there's an end while. Now, another way that someone might do it is they might put like begin loop up here at the top, and then down at the bottom they might say continue loop or something like that to show that that's going on in the pseudocode. So there's no hard and fast rules, just something that gets across the point that those 2 or 3 lines of code are the loop body, and they're dependent on that criteria, that condition. So pseudocode is pretty flexible when we get to looping constructs. Now, a post-test loop is one where we check the condition after we've already executed the loop body. So we can think about that happening after the fact. If we think about driving around town, we want everybody to kind of use a pretest loop logic, right? We want them to be looking ahead and deciding what they're going to do before they've done it. So we would like a pretest logic. If you're coming up on a stoplight, we hope that you would look at it. If it's red, you would stop, check beforehand. In a post-test situation, this is the kind of situation where you would drive through the light and then afterwards say, oh, maybe I should have checked that. You know, you've already gone through. So in Python, it's very hard for us to write this post-test loop logic. So we won't be getting a lot of experience with it. That's okay, because we can handle everything with a pretest loop like we'll be using more often. And the reason being is kind of like the stoplight issue. How often do we want to go without checking? So the inventors of Python were just like, we don't even need to be able to do that. It's silly. So we can't. But if I were using a language where I could, or writing pseudocode where I was trying to explain things that way, I could put it something like this: repeat this code body until some condition is valid. So that would work. And again, we could label it begin loop and say end loop while this is true, or however you wanted to phrase it, because we're looking at pseudocode there. Another way would be, we could say we'll use a do while loop. So both of those different looping pre-loop structures exist in different programming languages. We don't have them in Python though. So if you just think about how you would say it out loud with looping constructs, it's usually correct. So that's nice. Now we can have loops within loops within loops. This nested loop is thinking about checking for a parking spot. Like you want to start out, your outermost loop would be that you're trying to park. And while you're trying to park, you might go in and check the parking lot at Norman K. Myers. I don't know, maybe you count that one across the street over there. And if you finally find a spot, you would be able to stop all of your looping, right? And go ahead and park. But if you didn't find a spot, you would have to continue trying. Now, once you got done checking the Norman K. Myers parking lot and you couldn't find any parking at all, you would be done with the checking Norman K. Myers loop. But when you came out of that loop, you would still be within your trying to park loop. So now you would go to the next parking lot and try to park in that. And so we can be controlled by an outer loop that keeps track of all of this information for us. All right, we're going to visualize some of this. Let's get done with that. Loops are hard things to talk about. Here's our first program that I'd like for you guys to just put in real quick. Let me fix it here. I want to get some code copied out so that we can look at it. So if you would open idle, this is your like little review here since it's been a few days. Open idle and create a new file. And let's put in this program. Will it let you run it? You guys are speedy. And look, we pretty much have somebody side by side. I'm going too fast. Let me let you type. After you've got it in, of course, run it and see how it's working. looking, would you turn to the person beside you and explain to them what this program does? Go back and forth, line by line, and let's think about how we would want to comment it and what we can say is going on in there. Turn to that person. Now we have 2 rows of 3. Do you guys kind of work together, tell each other what it's doing?
Yep.
Of course. Okay, how do you feel about it? Did you explain it? I want each of you to explain it to each other. A reason being, one of our people who just recently got a really nice job said that was one of the big things in all of the interviews was they asked people to explain their code in the interview. So that's why it's super important for you to explain to each other, not just to figure out what this does, but to kind of get used to doing that. So if you have it, take an opportunity and say words to somebody else. It's almost like they know some of us don't like to talk. But I'm special. Okay, so first of all, what kind of variable is this up here at the top that's being declared? What data type is that? It's a Boolean. It's a Boolean. We know that because we just set it to a value of false. Now, that while condition says while not valid. So valid has to be true or false for this while loop to execute.
Must be true.
No, it has to be false
Because of the not, right? So it has to be false. So while valid is false, we're going to keep executing this loop. Now, our loop syntax, if you notice, is just like our if statement syntax in Python. The keyword while, and then followed by our condition, and then that colon character to end that while condition, because again, it has a body, so it ends with the colon. Now, inside our while condition, first thing we do is prompt for a number, right? And we read that in. Then we're checking to see if that number is greater than 10. And what are we doing if it is?
You set the Boolean as true that we believe that's.
So we're stopping our loop. Very good. Printing out a message about it. Then what about this print statement? Will this print every time the loop executes or only if the if statement is true?
Every time.
Every time? So it's the last thing in our while loop. What about this print statement? Is it part of our while loop?
Yes.
No, it's outside. So it's just going to execute at the very end. Okay, so this loop works fine. It's based on a condition of like a state, right? A state. Is the number that they've given us valid in our idea of what's valid? Is it greater than 10? Could we rewrite this without using that Boolean? It seems kind of like a lot of overhead. What I'm going to do, I'm going to open up a line and type in the 3 tick marks, the 3 single quotes, and then type them at the end of that code snippet that we just created, right? So I'm going to keep this code, but I'm going to comment it out so that I'm not using it right now. Now I want, there we go. I just pasted and you guys have to type. So I had already copied this off, and so I'm just pasting it in here. So this is the same loop, but now we're getting rid of that Boolean, and just using that number that we're asking the user for to control our loop. Now see if that one works. And we've changed our messages just a little bit so that you can see that you're working with the new loop instead of the old. Otherwise, it will still look exactly the same. But you should see the same impact. Now, neither one of these is right or wrong. I just wanted you to see the difference. How you can control the logic and decide how you want to handle things. Both of these while loops are top controlled loops because we're checking the condition before we execute the loop body ever, right? So we're checking first. If the condition is true, we execute the loop body. So they're top controlled. Now, if I started out, let's run this one here. So it says type a number greater than 10, and I can run my loop as many times as I want to until I'm finally done. I can type in a number that's greater than 10 to make my loop end. But what if I started out with number already higher than 10? Will my loop body ever execute? Right, because it's going to check that condition and be like, oh, no need to run this loop. It's already met this condition. So it'll just go on to the left to the statement following our loop body. So that top controlled loop will not execute at all if that condition isn't true the first time. So that's important because we could bypass all that logic that we think we're executing if our loop is not properly set up. So that means for a loop to execute, we need the proper initialization. So I'm going to put that out to the side here of this one. Idle's helping me. Let me try to tab now. And I'll say this is initialization. And then right here in our while statement is our test of our condition. And notice that our condition is based on the variable number that we initialized properly to make sure that our loop would execute. And then our input statement is causing an update of that variable. So within our loop, it's getting changed every time we execute our loop so that we can be sure things are going to work properly. So if we got rid of any one of those components, we could break this loop. Let's create an infinite loop. I want to comment out this whole line so that we're not updating it. And now let's run. So how's it going to stop? We can press Control-C to interrupt it because idle will let us do that. But that's just because we're using Python. So different programming languages on different platforms are going to give us different abilities or inabilities to exit out of an infinite loop like that. So we always have to be careful because they're easy to create. So make sure that that line of code is back and is not commented out because we don't want to do that. So within Python, we can use these while loops, and they're pretty straightforward, a lot like our if statement, right? While this condition is true, we're going to execute this loop body. So we can make things pretty complicated by nesting the loops within each other and doing lots of different things. But we have another type of looping mechanism we can use in Python called the for loop. And with the for loop, we can control things more through some sort of count type specification. Like we know that we want to execute something 10 times, so we can set up a for loop to execute 10 times. So we're going to do something a little different to work on our for loops. We're going to get out some different equipment so that you guys can get up and do some moving around and see what we've got. This is, see if I can get all the pieces here. This is a Raspberry Pi. Okay, here all by itself. And we've got some for you guys to try. And this is, I don't know what to say about it. It's like a $30 computer. So they were created, developed. When I was gone that first week or so, one of the things that I asked the sub to do was show you guys that code.org video, had Will.i.am, and he was talking about coding and his first circle and things like that. Well, code.org was developed in response to this cry for technology for coders in our country. Because I don't know if you guys realize it or not, but we were in kind of a situation where we had a national security risk because we don't have enough software developers in our country as compared to the software developers that are being produced in other countries. So a few years ago, there was this huge push, which you guys responded to, thank goodness, to get more people coding. We need that. We need the whole country coding, right? Pretty soon, kindergartners are going to have coding classes. So, but anyways, in response to all of that, the Raspberry Pi was one device that was created to try to make computing devices, low-cost computing devices, available to students as young as possible so that we can get more people coding because it's super important. So Raspberry Pi is like $25 or $30. It uses an Atom processor like a lot of phones and different things use. There are some newer ones that are available too that use different kinds of processors. If you only spend the $25 or $30, you don't get this cool little plastic case that it's in. That's another $5 or so, so you have to keep adding pieces. But for the $25, you get the little Raspberry Pi computer. And so it has a processor and it has a little video card built in. It has USB ports and a network port. Its hard drive is an SD card. So you can just buy whatever size SD card you want and pop it in there and that'll be your hard drive. So these are brand new. So you guys are going to be the first people to use them. So we're going to need to label them as they come out of the packages. They're already in their little plastic boxes, but we need to label them. So we're going to get them out, and we're going to try to label them, get them hooked up, and see what we can do. Now, how to hook them up. Before we get any equipment out, I want to show you. Each of you are going to have the Pi device itself. You're going to have a video cable. Half of them have HDMI cables, and half of you will have an HDMI to DVI, so you'll just have a different end on one side. The HDMI cable on one end is going to plug into your Raspberry Pi. The other end is going to plug into your monitor. So we're going to start out in teams doing this, and then after you guys get one all set up, you can split up and try to hook up a second one, depending on if you want to or not. We'll see how that goes. So if you're using the HDMI to HDMI cable, the HDMI connector on the back of the monitor is kind of towards the center, right beside the cable that's plugged in right now. Now, the IT guys have our wires so tight that it's going to be kind of hard to get some of these done. That doesn't mean it's okay to unwrap the cables, all right? They're not okay to unwrap. We have to deal with the way they've got them so tight and try to accommodate them with our stuff. So you want to make sure you know where that HDMI port is. You know, if I'm down there and try to get it hooked up, I'll do it with this one here real quick so you can see it's not the end of the world. So video cable. Next thing we need for our Raspberry Pi is keyboard and mouse. Not going to be easy either. So your keyboard and mouse are right here on your little teeny tiny computer, down at the bottom, and they're right beside or right in front of your network port. I've gone around the room and checked them all and make sure they're all the same. So I'm going to reach down in there and unplug those USB cables from the back of this computer. Now somebody's already messed this one up. We'll get yelled at. Actually, I'll get yelled at and then I'll yell at everybody. It's all messed up. Okay, so I've got these two USB cables that are not going to cooperate. They're stuck back here. So I'm going to plug this Raspberry Pi in back here to those USB cables. It doesn't matter which one I use. So I'm not going to do that yet because I already showed this to you. Third thing I need then is power. So to get power, I'm going to use the computer itself. So I want to plug in my power port here on my Raspberry Pi. It's just a standard USB power that looks just like a phone plug-in. Get myself right side up here. Now the Raspberry Pi doesn't have any sort of on-off switch or anything like that. So as soon as you plug this in, it's going to come on. So make sure it's got keyboard and mouse plugged in, video plugged in before you turn it on. Now, how to plug this in to turn it on. On the little teeny tiny computers, we have a special USB port that produces power. Again, it should be the one that's open here on the side. So when you plug that in, you should get power. And I have checked all of those too. So you should have two USB connectors on the side. One that's your USB extension cord that's already used. Leave that one there, and you're going to plug in to the other one. All right. After we've got all that done, we're going to see if they work. And then we're going to shut them down and hook up these fancy breadboard things. Now, I want to tell you all of this before we get too messy. The breadboard things are going to allow us to use Python to control these little LED lights. So once we get our Raspberry Pi all hooked up to the computer, we're going to get out these breadboards and see if we can configure the wiring like this example. It's pretty simple. We'll leave it up here and we'll all do it the same as this. And then we'll be able to use our Python code to make the little light turn on and off. And so we can run our for loop to get a visual. So it's going to be a lot of work for us to get the visual of the blinky light for our for loop. But it's going to be worth it because we get to try the Raspberry Pi so you guys get to see this great technology and see how it works and see what's available. Because as a developer, software developer, it's important for you to know that these things are out there and that people who say they can't afford a computer or whatever, I'm sure you know lots of people who have a phone that costs a lot more than this that say they can't afford a computer. Well, you know, we do have to buy some extra things for this, but in general, it's pretty cheap. Now, the other thing about a Raspberry Pi that's super important for you guys as software developers is, have you heard about the Internet of Things? Have you heard about it all? Where, what, your refrigerator, you can connect to it from your phone and it will tell you that if you need milk, right, what you're missing out of your refrigerator. Most of the Internet of Things devices are powered by Raspberry Pis and Arduinos. So the Arduino is another thing that's just like the Raspberry Pi, just a little different focus. But any sort of Internet of Things development is happening pretty much on a Raspberry Pi device. So as we are creating this connection in making the LED on the breadboard blink, keep that in mind. This is just the first step in a series of steps that could lead you to development in that area. It could be something that you're really interested in, that you want to, that you believe automation is an important thing. I think there's some great things coming that we can do with Internet of Things devices. Okay, so labeling, we're going to put one label on the top of the plastic thing and one label on the breadboard. But I'll probably do that as I hand them to you. Now, in order to facilitate us getting this done, we're going to partner up with the people that you are beside, okay? So I like to mix you guys up and not actually have you work by the person you're beside, but I want you to work by the person you're beside for this one because I don't want you to have to move around a lot. Do you two, is it okay if you two are together there on the end? Is that all right? And I think then we'll be even. Okay, I'm going to hook this one up here at this workstation so that you can see it, and then we'll have the breadboard as an example. But come on up with your partner and let's get a Raspberry Pi. I've got a big mess, so let's see what I need to do. Hang on, let me get boxes. I thought I had everything ready, but there. My favorite thing when I used to teach people when we would build computers, like opening up all the parts to build a computer, and it would be a big giant huge mess. And I would be exhausted for days. It was always fun. Okay, so first one I've got a video cable. A power cable. And okay, now I'm giving you guys SD cards because they're all freshly loaded and stickers. Hopefully you'll have everything. So let me know if you're not feeling confident putting the SD card in. All right. I'm going to run out of labels here.
Am I working with all three of them? Or?
No, she on the end is going to work with the one behind, so just you two. Yeah, you're with him. And then these two are, see those. Thank you. Yeah, one for your pie and keep the other one for the bread. It'll be a little while before we get done. Let's see. I think that's a photo. All right. Now note where that SD card goes and I got enough. I need two more. Okay. My batteries are going. Of course.
I'm pretty sure it's
I've had this label maker for so long, and I was like, oh no, I forgot the batteries are fucking dead. Oh my God, through the screen. So I'm just glad we got all of these. All right. Okay, good luck. Okay, everybody set. A few more here. You can.
Oh, wait, no, it's good on.
No, the problem.
Maybe.
Oh, yeah, it's on.
Oh, wow, that's so cool.
Is it the computer?
Yeah.
It's beeping.
Yeah, it's not.
I'm not sure what's beeping.
I think it's right there.
It's that one.
Yeah.
Is it dead? Is it
No,
on?
it's like flat, but,
Oh, it's flashing red.
yeah. Should we turn it on?
Oh, wait, no.
Yeah, let's try.
Well, no, I think. Oh, that one, like this. And then
Yeah, let's try the computer next to it.
Next to mine.
Yeah, and see if it does the same thing to it. We might have to get a power cord. We just don't have enough power for all the movements.
Yeah.
Enough power cords.
Oh, that's so cute. Wait, oh, so we're just moving the power over. Oh, yeah, those are I know, I did not like that.
It's okay now, huh?
It did not like that. Yeah, it was really weird.
Yeah.
We're supposed to be getting new keyboards and mice for these things, so hopefully you guys won't have to do this again with these keyboards and mice. It's working.
I'm always so very much about